Yo.
Yeah, that was. This homework was fun.
I didn't expect everyone to do all of them. Said as much as you could.
It's fast.
But it's good to try.
Yeah, it was good.
I mean, there's like 20 of them, so,
Yeah.
yeah.
Yeah, and I was like, that's gonna pick one of these.
Yeah.
So, let me see what you pick. Some I'll, do Fibonacci numbers. Oh, you said Fibonacci?
Fibonacci.
Fibonacci, right.
Fibonacci. All right, yeah, so we'll start today with a warm up before we get into the main content. So I'll give you about 10 minutes to attempt this one if you haven't already. If you've already done it, then you could try one of the other ones that you haven't done potentially, but I'll work through this one at the beginning of class. So let me post this in Slack. All right, 10 minutes. How's everybody on the call? Somebody say hello.
I can hear you. Hello.
Hello. Or if you've already done it, try to solve it in a different way. There's one way to do it.
Good morning. And he's got the assignment on the board and link in Slack. He picked one out of one of the activities I'll work at. Pick down somehow out of So what is that? I mean, it's not, we're not in data structure all here.
It's under intermediate algorithm.
Because I was going, that's what I was. I don't remember this even. There, gone here.
Apparently, there's some weird divide happening here.
Academic pool.
Hey,
You guys voice out on that side now, it's all this side.
yeah, more innovative in their approach to training. We're doing it the old way. You see how it feels. at the end. I get lost in this stuff sometimes.
Hey,
Sunshine. How's it going?
a quick warm up. No, today's like a normal class day.
Yeah. Good. Classes have been fantastic, virtually, so. Otherwise, I'm enjoying, got a lot of it.
Yeah, I was in Cozumel.
Oh, no wonder I got so much out of it.
Why did I what? Oh, invite you. I was like, why did I lie to you? I was like, it's like you could see where I was. Yeah. Okay, so, these algorithm questions, they're, kind of contrived, like this isn't really something that I have to deal with on a day-to-day basis when I'm solving problems at work. But they're fun and they're also like, just good practice, sort of like brain teasers that do touch on some of the skills you need for the like larger, more realistic problems you'd be solving at work. And if you find these fun, then that's probably a good sign that you would like some of the more back-end programming type stuff. And if you hate this, then that you probably a sign that you would like the front end stuff more.
Be open-minded.
Yeah, yeah, yeah. When I was first starting off, I found these to be really fun. So, and these are also something you probably don't want to feed to ChatGPT. Like it'll be able to crank out an answer really easily. And the point of these is to kind of flex your like ability to break a problem down into smaller pieces. And that's like an essential skill to retain even in this age of ChatGPT. Because like you have to figure out, you have to break the problem down enough to be able to feed it to ChatGPT. Yeah.
What the result should be.
Yeah. So, this one, there's two ways we could solve this. We could use recursion in this, which you guys were recently exposed to with the whole prompt thing. But you could also just solve this with like a while loop or something. What did you all do? If you were able to figure it out, or what were you trying to do? Or did we not get there?
I was still just working through it, so I
Yeah.
should be able to do this, but I had to call it.
Yeah. Yeah.
I think there's a story about how the Fibonacci sequence got like figured out like 30 times as well. Some guy in class figured out or something in class.
Yeah.
I don't remember any words. 16th century.
Yeah. I mean, you also may have done like a for loop or something potentially.
I was working on,
Yeah.
I was just doing the Fibonacci sequence first, trying to get that part down to get that logged in, and then I already had the odd number first figured out.
Yeah. Yeah, the
Use the previous the current
That's what I was working with. Like that.
yeah, the only reason a for loop is kind of awkward is like the next number to go to is derived from like the previous two numbers, and it's not like this straight sequence from 0 to whatever number they pass in. I mean, you probably could achieve it, it's just going to be awkward. I
Yeah.
think it's just gonna be kind of weird. Because like really what you need to do is you need to keep track of, well, like, so if you break this problem down. We may have to wait just a second. Hey, good morning. Sorry, we're having an air conditioning break here for a second. We can probably start using that room, actually. Okay, we'll just power through it. So. Typically when you have a problem like this, you want to just start breaking it down into smaller pieces and just solving those pieces. And then hopefully you'll kind of start as you like break it down and like create some of the pieces you need, you'll maybe start seeing like what the next step should be and just kind of tackling it that way. So one of the first things I think of when I see this is, well, obviously I need something that figures out if something's odd or not. Pretty straightforward. So we know we're gonna need that. So you could start, like, if you're like, I have no idea what to do, you could just kind of start just tackling some of the smaller pieces just to kind of get those out of the way. So you could, I mean, this is pretty arbitrary, but you could add a function for is odd that would take in a number and then would just return number mod 2 triple equals 0. Or
Be
not equals, yeah. Shoot, this doesn't work the same way my code editor does. Yeah, so this would, if a number is not divisible by 2, then it's odd. So this is one piece of the problem done, check. So maybe that'll make you feel a little more confident. So after that, though, the next step is, well, I need some way to generate the like next number in the sequence, right? So I'm at a certain position in the Fibonacci sequence, and then I need to go to the next one. So that would look like, I mean, we could also write a simple function for that. So function next number would be previous current, and we would just return previous plus current. All right. Okay, so I've got an is odd thing, I've got a next number thing. And so when we start this, like, so now we kind of need to figure out, like, we're gonna start with the same 2 numbers always, right? So we know that the beginning of this thing is like, well, maybe yeah, let's use const for a second. So like const next would equal next number with 0 and 1, right? We know that that's kind of how it always starts. But then now we need to sort of like keep doing that over and over again, right? And we need to keep doing it over and over again until what?
Until we get the target value of like 10 or whatever.
Yeah, and what's the target value? Num, yeah. Yeah, so there's something that's gonna look like. Is next. I think we want to include it, right? Less than or equal to num. So is next less than or equal to num? Like at some point, we're gonna do that, right? We're gonna say like, do we need to keep generating the next number or not? Okay, so now there's like a few decisions to make, and there's in certain times people will choose to go one route over another purely because it might be more performant, like meaning it would take up less memory in the program or it would be faster. So there's in these algorithm type things, a lot of times that is a consideration that people consider. So like if an algorithm is twice as fast as another one, we would choose that one any day. Unless typically performance is a big reason to choose an algorithm. So like one thing we can do is like for the first step, we could say, hey, let's like generate an array of just every number in the Fibonacci sequence, right? Like, let's just do that. So let's just have a while loop that goes up till, I don't know if you guys remember while loop, because I was like, you don't really need to use that very often. But like these algorithm questions are like often where you will use that, but often you're not doing algorithm questions like this. But we may use a while loop, and we could say, okay, just like do a while loop and then just keep pushing to an array the numbers in the Fibonacci sequence that we need. And then we'd have an array of all the Fibonacci numbers. And then we could use like what array method to get that down to just the odd numbers. Filter, right? Then we could do filter. And then we could just do a reduce on that, or we could do like a loop that then just sums every number in that, right? So that would work, but that would be considered a less efficient algorithm by a small amount, just because we're using memory to create all those numbers in the array. Like we're like storing a bunch of information where we could sort of like basically as we're doing it, check if it's odd, and then like just sum, like mutate the like a variable that we're storing that's going to be the end result. Like we basically just say, hey, like we're going to store the end result and then just continue to add to that when it makes sense to do so. So that would be, so you could have tackled it both ways, but there would be a slight preference for the one that doesn't use as much memory. Though it's like, then we're like mutating something, and I've talked about not doing that as much, but algorithm stuff is where kind of a lot of that stuff gets thrown out the window for performance reasons. Okay, so we know that we probably need like a let final answer, right? That's going to store the sum of the odd fibs, and we can just set that to 0. So we can kind of start with, we know we need that. I would probably change this to like let current equal that.
Instead of a constant.
Or maybe, I don't know, maybe I would do like, so I haven't solved this quite yet, so I'm kind of doing that on the fly right now. So like I'd probably do like let like 2 prior, and then let prior,
One prior.
yeah. And then something like. If. Okay, so when we're doing this thing, we know. That if it's 1. So these down here, these are cool. These are called your tests to verify that that your algorithm is working. So it's often helpful to kind of look at those and walk through what you're going to try to do based off that.
When I first tried this. And I ran my function, I crashed my brakes.
Yeah, so you made an infinite loop. Yeah. Yeah. That's very common. I've done that so many times. Yeah.
I was just surprised that the program didn't stop it or anything.
When a browser hits an infinite loop, like. There's nothing it can do. It's just like stuck at that point. Yeah. Okay. So when we do 1, it's going to be 0, 1, 1 are all going to be in that sequence, right? Because 1's in there twice. And so I think the answer would be 2 in the case of some fibs 1 should return 2, I think. So we know that like, no matter what you do, unless you give it 0, which I don't think they would do. That would return 0. I don't see that in the test, but maybe you should consider that. But no, given a positive integer. So based off how they're telling you to describe it, you won't ever get 0 because 0 is not a positive integer. So when we get 1, we know we need to return 2. And so in that case, we'd have 0, 1, and then next would be 1. And so we would need to sum up all those. So we know that. Where's my sum? Did I get rid of that?
Never, yeah.
Well, next I want to be like the next number in the sequence kind of thing.
Oh, right.
So I'm gonna do like, maybe I'll just call it sum. So let sum. I think what we could do to start is do let sum equal 2 prior plus 1 prior plus next, which would be 0 plus 1 plus 1 to start. And then we'd say, okay, if there's another one that we need to do, then we would just get next and add next to it. Like we wouldn't need to keep doing 2 prior, 1 prior plus next. We just need to add the next one each time at this point. Yeah.
Yeah.
Okay, so this should work for. So this should work for 1, right? So we can do return sum. Oh wait, but we haven't done is odd. But we don't need that quite yet because 1 is odd. Okay. So now the only piece that we're missing is like this generator thing, and we're also not using is odd quite yet. So I think what I'm going to do is I'm going to say while. Wait, hold on.
So for the sum. Yeah. Why would you add next? At the beginning instead of like just in the while?
Why would I do this?
Because what if your let sum equals 2 prior plus 1 prior, and then in your while loop sum equals sum plus your next. Where you're, I don't need to.
No, you're good. I think it's a well, So in the first case, if we're at 1. Next would be less than or equal to num, and so it could add it there. Yeah, so I think you're right. Like we would. Yeah, that would actually be a bug because we'd be adding 1 twice, I think. And yeah, so I think you're correct. Yeah, so while next is less than or equal to num, which would be true for like next would be 1, which is going to be less than or equal to 1 if that's what we passed in. We would do well, we could also calculate. Well, we would do sum equals sum plus next, and then next equals next number. Well, actually, we do.
You have to set 2 prior equal to 1 prior. 1 prior to next.
So we'd have 1 for next. It's just the variables are confusing, but
Think about this, we actually keep track of so many different numbers at the same time and.
Yeah. but then we don't want to do sum unless it's odd. So we would do if is odd.
You have to do like, that is odd, or is it just like taking you whatever the rules?
Well, it's whatever's next. I think. I don't know. I'm a little. My brain is all twisted.
Yeah.
Yeah. Well, yeah, sorry, this doesn't work. Why would I do 1 prior equals next? Because this will just be the same number twice. You're right, Jamie.
Putting a console log in the while loop. So it's- while loop.
Okay, I think we're close. Sorry. This is like my brain like turns off when I'm doing this all of a sudden in front of all of you. Okay, so I don't know if this is right quite yet, so we'll run it, but it might cause an infinite loop, which is what happened to you before, but we've got two prior and one prior as 0 and 1, and then next equal to 1. I'm not sure if that's right. So we'll do sum equals 1, and then next is less than or equal to num. To start with 1 less than or equal to 1 is true, so 2 prior would be come 1, and then 1 prior would be next, which was 1. And then next is going to be 0 and, or no, it's going to be 1 and 1, which is going to give us 2.
Would you also put the two prior? Everything in your while with the two prior, one prior next, wouldn't that also be is on check?
No, because we still need to generate the Fibonacci sequence correctly. We don't want to just generate odd Fibonacci's. Well, I mean, we sort of do, but we need to go through the Fibonacci sequence correctly,
Right.
but then only add it to the total if it's odd. Okay. Okay, so Okay, so now you're just gonna start testing it. So console log is a good way to do that. And it looks like, I don't know what, oh, it's like actually, whenever I type, it's actually running it for us. Okay. So, and it's got 4 in there to start. So I've got a console log. I'm doing this object style thing here where I've got like next 2 prior, 1 prior inside an object, just so it'll auto label everything for me. And then I've got some down here inside of an object, so it'll label it. So you can see when it's logging it, it's showing me next is 5, 2 prior is 3, 1 prior is 5, and some is 9. So the first time this runs, we get 1, 1, and 1. Where am I logging this? That is such a hard thing to understand. Looking at that, I'm just gonna log some. Okay, so I'm just changing it to only log the numbers that it's identifying as odd. So we get 1, and then 3, and then 5, and then 13. And then let's just see what numbers we're generating for next. Okay, for some reason, we're generating 3 twice, 5 twice. Oh, no, that's just because we're logging it. Okay, this actually looks correct to me. Okay. So it looks like this is correct in terms of it generating the sequence. We don't have the first 1 in there, so we'll just have to consider that because 1 should repeat twice. So I think we could. Start this at 1.
It seems like it's skipping one. When you have the console log, you have the 2 prior and 1 prior in there. It seems like it's skipping that.
Skipping which one?
So if you add, in the curly brackets, 2 prior, comma, 1 prior, comma, next. And then you see them. So I'm seeing like 2 prior 1 prior 2, next 3. 2 prior 2, which is right, 1 prior 3, next 5. And then the next row is 2 prior 5. So like every other row, it's like skipping. It seems like it's skipping
Part of the sequence there.
I don't know.
But like, we look here, it's generating that. So we don't have 0 in the first one here, just because of the way we set this up. But then 2, 3, 5, 8, 13. 21. 34 looks right to me. Right? So I would think,
So is it an issue to while next less than or equal to known, then your modified next?
it's gonna go too high.
Yeah, I'm just.
Yeah.
Should you do another? If next is less than or equal to known, then do the sum plus the next.
Oh man, we spent way too much time on that. I'm sorry. Dude, my brain went to complete mush while we were doing that. But hopefully that makes you all feel better. Okay. Yeah, so. I think the lessons there though are like, you may not be able to just like keep all this in your head and be able to perfectly do it the first time. You need to console log stuff and kind of look and see what's happening and just test it. And that's why they provide these test cases for you to kind of walk through to kind of see if it's doing what you expect. I think what's so tricky about these also is like when you're doing this mutation, like next 2 prior 1 prior just kind of lose their meaning.
Yeah,
And like they are kind of changing, and so that's why people prefer not to do mutation, because like the variables stop meaning as much.
that's why also, I mean, console log really is your best friend, like for me, the way that I made sure I got that right, I had, 0, 1, 1, then 1, 1, 2, then 1, 2, 3, then 2, 3, 5, it's just doing it every time, so I keep track of every single number. And I don't know how most people do it, but I do like 6 million console logs when I'm testing, but I just do it later. Or I
Yeah,
forget my code.
yeah. Yeah, and honestly, like this is probably harder to read than if we had done the first like less efficient style that I had described of just like generating the array and then like filtering it and then summing it might be a little bit cleaner. We don't have time to do that version though, unfortunately.
Well, I think it's all
Yeah.
good, the performance stacks up as well, so if you have one less performance thing and another, eventually.
Yeah. Yeah, but we can see what ChatGPT would have done with this.
But
No,
function. When are you gonna teach us about debt?
that's Python.
I know.
Okay. I don't know what temp is for.
Oh, yeah. Yeah, I was using 4 variables, not that I got it, but that's good.
Okay, they don't have like a separate next
No.
number function, yeah.
They wrote it like a robot would.
Yes, this is pretty close to, so they're doing, prior number, first number. They're starting with some 0. And then, yeah, I don't know why they're, doing while b less than or equal to number, but pretty similar. They just didn't break it out into other functions or name their variables the same. But yeah, okay, sorry, we spent way too much time on that. We have to jump to the stuff that we're gonna be doing today. Yeah, I mean, you'll see these algorithms a lot and people like practicing them. And so I think it's a good thing to try and just kind of get used to trying to think through them. But it's definitely not a representation of what my day-to-day is like. I'm not ever trying to solve the Fibonacci sequence, yeah. Okay, let's take a quick break and then we'll get to the stuff at hand today, which is what we're doing today is we're learning about asynchronous programming. So we've mentioned synchronous versus asynchronous, but we haven't really touched on it, so we'll do it today. All right. Sorry about that, but maybe a good lesson, just that some of the stuff is pretty hard. So, all right.
Well, it's good to know that you don't expect us to be like at that level yet of like. Oh, God, just like figure that out, because I was in the impression, I'm just a bit behind or something.
It was a little disheartening, I think, if you're like, all right, let's do it, okay, done. Like, okay.
Yeah. Yeah.
Yeah, I mean, that stuff is complicated, like you said, you don't normally have to do things like that, and it's already in the back of the overall nowadays, but it's good to just flex your noggin. There's some days where I'm doing this stuff where afterwards it feels like, when you work out, I feel like when your arms are squared, it's like, bro, you just like.
Yeah.
And kind of rest for a second, stare at a screen or something.
Yeah, I do my coding homework after I've been coding today.
Yeah.
So then I'm just trying to get it over. Tired, staring at my computer. It's a good challenge.
Yes, it is. I need to get caught up, and this weekend should be my chance to finally get right back on practice. Today was just so long. Great forest and all that fun stuff, and having to cover for people. But now we're done with it, so. And my boss, I mean, he did let me leave, 5 hours early one day to work on things, pretty thick.
Yeah.
I was like, hey, by the way, can I got some stuff I need to work on, can I go, like, at some point earlier? He's like, yeah, you wanna head out? So. This stuff is fun, though, it's, I don't like it quite enough to do, like, I have a friend that plays video games, where they just have like a made-up coding language that she has to learn, and then type it for that game exclusively. I don't think I'm quite at that level, but I do like doing the actual practice stuff that I use later.
You know what game that is?
I don't have to ask her, she has like 5 or 6 where it's literally like a fake. Is that the kind of thing you use to play, or? Just wondering.
I think I've started it essentially.
It's crazy how many of those things there are. I feel like I look at Guitar Hero where I'd rather just actually play the guitar.
Just say, hey, they made it for modern consoles.
Man, I don't know, like I do like playing on like a party game, but yeah, they try to bring it back with like. They did like Guitar Hero and try to rebrand it. I think they're like they game per song or something.
When was that?
It was, well, there is one game though. What is it called? I'll give you the name of it. There is like Guitar Hero on PC that's basically exactly Guitar Hero. But it just has custom songs made by people and they're just like infinite root songs that later on it.
Like I want the Switch one that had, or I wish I had one on the Switch, and then I really like Rock Band drums too.
Yeah, it was great.
Yeah.
Yeah, it wasn't that stupid drum that set up in my room as so it only took up space. But it's like, I had the symbols, I think it was one that had the symbols for me.
Honestly, I would love it if it had just like a regular drum kit. And so you could learn how to play drums that way. It's so fun.
Yeah, the drums I thought was one fun. I just wanted to get into, I never did, Rocksmith, where you could like actually play the guitar and it was here.
I've heard of that.
My dad played a little bit, but you had to have, this was back in like the Xbox 360 days. And you had to have like 3 different adapters to make it work right, and I just never wanted to move them up my dad's Xbox to mine, so I just never played it. I just practiced regular concepts, but it seems like a good way to learn doing that kind of gamifying of it. I mean, it's the same stuff with this though, like they give you these talents to do the coding, and then you actually have like little points of progress versus just sitting alone in your room writing code, you're like, oh, I believe it, I figured it out.
In the really current iteration of the Guitar Hero, this games, Beat Saber.
And Beat Saber's code, there's a new slot. I love Beat Saber that. I mean, it's one of those games where you don't really want anyone to ever see you playing it. But it's a lot of fun to just like sit around. You know, literally, I was playing in my room, someone, my grandma's working for some reason, and she opened the door and I hear like, hey, like that. And I take off my headset, because I didn't know you interrupt your whatever you were doing there. Like, don't worry about it. I mean, that's a question. Something get me in front of you. Yeah, we should remember the name of that other guitar hero. There is like there's a very alive scene for that kind of thing where you can use this guitar. It's called.
I wouldn't be surprised if there's people that like workshop and always version of the game.
Well, there have been people that have been like modding it. I think it's specifically like Starter World 4. And so it's modded now, so it's like, you know, Daddy and Batman, whatever was on screen. Yeah. Because the game that I was playing was called Clone Hero. And so it's literally just be plugging the card here on it, and it has like the same for Edward. Every time I started playing actual guitar and then played Guitar Hero, I feel like I'm basically I have a really impressive picture. And it would be more.
All right, let's hop to it.
Don't come back in.
Oh, yeah, sorry. Okay, so. Okay, Maynard. Don't know what that is. Okay. So we talked about the 2-pass system before where it like goes through and makes the variable names and then creates any functions you've declared in the first pass. And then the second pass, it actually runs through your code line by line. So, you know, when we run this program, first name would, last name, greeting would all get sort of slotted. And then when it runs in the second pass, it would assign Zach to first name, Maynard to last name, and then hello, my name is Zach Maynard to greeting. And that would be the end of the program. And there would be, you know, specific sort of line by line order there of, you know, line 3, then 5, then 7. If we, you know, add a console log of greeting, you would see what you expect to see, which is that that greeting being logged after all of that stuff has been defined. So we can go ahead and run this program.
Is there not a built-in console log in Visual Studio Code?
I think there is.
Or is-
What does that mean? Like, what do you mean?
Like, so this entire time we've been opening up the web browser to give a console log, is there not a built-in log in Visual Studio Code?
We used it last week, use the term.
Yeah, well, there's a built-in terminal in VS Code, but not a browser. Well, when you said like we've been opening it in the browser, well, that would be the console in the context of the browser, which I remember if you're running the code in the browser versus running it in Node, you have the same language that you have a different set of APIs available to you.
Because we were running into an error the last, we were trying to do it on, I think it was VS Code, and we couldn't get it to work because we didn't know what to do with stuff, fucking great. That was last Saturday.
Yeah, I don't have to go, I'm kind of old school, so I don't have to go to the terminal. Like a lot of people will open the terminal in VS Code. So you can go to new terminal up here, and then you get this like split
Yeah.
thing. This is still running the same thing as this, like it's the same thing.
Okay.
I don't know.
Mine worked.
But yeah, so, and it's the same commands, like it's, you know, I still use CD and all that.
You can have the node functionality there.
It's the exact same thing.
Exact same
It's the
thing.
exact same thing. Yeah, yeah.
I think he said for
I think it was Windows, yeah.
Well, you have to do this, there's like a drop down up here to go to Git Bash instead of like PowerShell or whatever, which you would want to do. Okay, so, but yeah, I can do node async JS to run the program. So, yeah, we get, you know, hello, my name is Zach Maynard. This is a synchronous program. There's nothing in this file that would cause the program to not run in that way of first pass, two pass, and then line by line in the second pass. So basic things like declaring functions and running functions and you know, assigning content to variables and things like that, those are all synchronous, meaning they just happen immediately. There's a lot of stuff that you do when you're writing a program though that will cause it to not run synchronously. And the reason for that is it's doing something like more complicated. And the best and most common example you're going to deal with is when you want to talk to an API. So and you can do this from the backend or the front end, like so, and meaning you can talk to an API in the browser, which is happening all the time when you use a web app. Like it'll talk to.
Quite used to barrier.
Sorry, say that one more time. Sorry, I couldn't hear you if you were asking a question. Yeah, so when you load your HTML, like when you think about your basic coffee shop that you loaded into the web browser, like all of the data was coming from the code file, like the HTML file you wrote. But normally in a more advanced situation, like your coffee shop front end would then be like talking to an API to ask for like what's on the menu right now. And like how many do we have of all those things? Like, is this sold out or not? And so your browser needs to be able to talk to an API and get information from it. And then sometimes your backend code would need to do the same thing as well. So we can talk to an API from Node or from the browser. And like another example would be like, maybe we want to get real-time weather data. So there's like a, you know, weather API available to you. And you could talk to that API and ask it for like, what's the current weather in this zip code or in this location? And it'll respond to you with JSON of like that current data. So when we need to do things like that, which is very common, like we commonly need to talk to APIs to get information or to run a credit card transaction or to like do very, you know, sophisticated things for Uber to say, you know, here's this person location, like what cars are around it right now. Those are all like questions you need to ask an API, and that process of which is talking over the internet. Like that's what that is. Like talking to an API is making requests over the internet. And it's just like, here's the URL of the API and here's the information I want. Like there's a way to sort of specify that we'll learn about. And then it'll respond with that data. So that process of talking over the internet is not immediate.
Like it doesn't happen in milliseconds. Like whenever you assign a string to a variable. It doesn't happen I mean, it happens fast, but not that fast. And also we don't know how long it will take. We actually, like, it's not a known thing because it's got to like go through a wire and like it could be further away than some other server. Like, so like this is where we like, if you're running a server, like remember when we ran a server on our computer at one point and we had our browser talk to it, like that's happening through your computer really, really quickly. But that API could be somewhere else. It could be in like the East Coast or the West Coast, or it could be in China. And depending on where the IP address resolves to, like it's gonna run through a literal wire all the way to it and then all the way back at the speed of light though. So pretty fast. And so we don't know how long that's gonna take. And so that's an asynchronous thing, meaning it doesn't, like we've written our code in a way to where that can happen when it happens, like when it's done. And it doesn't, like, our program's not going to, like, the actual execution of our program will not be line by line. It will be something at a line at a particular point that kicks off that request. And then your other, like the rest of your code will keep running. And then whenever a response is received, then there's a callback to run whatever code that you want. So that's a very common use case for needing to write your code in an asynchronous way, so that it basically you can say, hey, kick off this event or kick off this action, and whenever the response comes, then run this other code. So you need to be able to write code in that way.
So if you have two functions, one takes a little bit longer. So they'll both be executed at the same time, but the return could be different between function A and function B.
The return, like timing or
Return time.
Mhm.
And then, so in function B, if you're wanting to use whatever's returned in function A, then that's where you have to start doing the asynchronous functions to wait.
Function B would wait for function A, essentially return that value and then proceed forward. Is that?
Yeah. So well, I'm not quite to, like, so the way that we do this now, and the cleanest way to do it is with this async await syntax that maybe you've seen, but I haven't shown you all. So there's a specific new syntax where you can mark a function as asynchronous, and then you can await the result of it, which is like a really nice, like, this is a asynchronous function. It's going to make a request that could take 2 seconds. But if I put like a wait in front of calling that function, it'll feel like it's synchronous in your code when it's not actually. So we'll get to that syntax. But there's a few things we need to cover before that. Yeah. So let me just give an example of this. So there is a sort of an arbitrary thing people use to demonstrate this concept at first, which is a function in Node and the browser that's called set timeout. And it's simply saying like, hey, I want to do this in like a second or in 2 seconds or 3 seconds. And that you could use that for various things, like when someone first loads the page, wait 5 seconds and then pop up this modal with like, do you want to subscribe to our blog or something, which I'm sure you've done that before. So it's sort of like, that is an example of like, hey, kick this thing off, but then I need you to run this code after that time. Yeah. And so an example of this we can do is we can call that function set timeout. And there's a few different styles of how to handle asynchronous code. One is with this newer thing called promises, which is what is being used by async await. Okay. So there's a few new there's two big new concepts today: promises, and then the async await way of working with promises. But those are newer things that were added to JavaScript And you just need to know about how we did it before that was introduced, which is callbacks. And you'll still see callbacks used sometimes when it's like simple and you're not trying to do a bunch of stuff. But callbacks created this thing called callback hell that you might see referenced, which is when you need to like, you were asking like if you need the result of something for another thing, like if I need to make a request and then from the result of that request, use that result to make another request, and then so on and so on, you end up like having this like deeply nested callback hell thing where you've got like your code is like indented really far. So but you'll still see callbacks used. And basically, just like we saw with like the filter method, when we have an array and we call filter, the thing deciding what to include was a callback function. Like we passed the function a function saying, you know, you're going to deal with looping through this thing and you're going to deal with creating the new array. But then, so I'll do that for you, but you need to then tell me what you want, which is the like, you know, give me everything that's even or give me everything that odd. That's that function that describes what you want, right? That function is the callback, is referred to as the callback. Like it's going to call your function for you. That same concept is used for asynchronous stuff too, which is, hey, I'm going to do something asynchronously for you. And then when it's done, you need to give me a callback. I'll call that function whenever it's done. So like if we want to kick off a request, we need to give it a function that will process the response whenever that happens at some point in the future. And so set timeout is set up that way. We call set timeout, and then we give it a callback. So we can do an anonymous arrow function real quick for what we want to do in whatever time range I want. It's called the timeout. So we might want to do something in 2 seconds. So I can, and it's in milliseconds. So 2000 milliseconds is 2 seconds. So that's the setup of the set timeout function. Hey, I want to use that, do something in 2 seconds, and then here's the function describing what to do. That function doesn't take any arguments, or usually you don't need to. And we just need to say what we want to do in those 2 seconds. So we might say, okay. So it's not really. Okay, so if we have this program, first name, last name, greeting, all get defined, and we have 2 console logs, right? Now, with what you know now, what do you expect this program to look like when we run it?
That, you know,
You have that, and then another one should pop up after 2 seconds, right? But the bottom one would execute first, and then the top would come after.
Yeah, that's right. So now this whole like what happens in this program isn't this like line by line thing anymore. It's, well, what is synchronous, that will all happen first, and then asynchronous stuff will happen when it happens. And maybe before another synchronous thing, it may not be, most likely not, because most like the execution of a program is so fast. And like any asynchronous thing, even if I said 1 millisecond, is going to be longer than the typical synchronous thing. So yeah, basically now when you're reading the program, you would say, hey, okay, kicking off the set timeout happened before this console.log, but the callback isn't going to happen until after this console log because of the asynchronous piece of saying happen in 2000 milliseconds. That's the same thing. Sorry, go ahead.
Oh, no, I don't want to interrupt you. I was just gonna ask, is there like a way when you're working on something like this that people usually like mark the asynchronous stuff, or are you just gonna have to train your eye to look for it? Because I feel like that could get really confusing really fast in your code if you're not already familiar with everything.
Yeah. You sort of have to train your eye for it, but you'll also see people usually using the new style, which is they'll mark a function as asynchronous and you'll know, yeah.
Okay.
But the callback style is still used. I'll show you where, example of where. So, yeah, so let's run this program though and see if it does what we expect. And notice the program stayed running until after that. Like, so basically the way a script will work is it'll run, it'll process everything, all the code, and then it will check and see if there's any jobs that it kicked off. And if it has unfinished jobs, it'll wait for those. And once those are done, then it will exit the program. So that's what happened here. So we see the first log and then the async log. Okay. So that instead of that set timeout, it could have been an API request. We said, you know, hey, make this API request. And then we could have a console log the response of that API request. And it would have been very similar to this program. And then we would have seen the greeting and then the log of the API requests happening a few seconds or milliseconds. API requests are pretty fast. They're still milliseconds. But it would happen after. So that's synchronous versus asynchronous. Like synchronous meaning one by one in a line, asynchronous meaning one by one, but then kicking things off that then may happen whenever they do happen. And it may intercept the line, it may not. It just whenever they're going to happen, they happen. Okay, so another example of asynchronous that you may see in Node is actually when we read a file. So typically when we read a file from the computer, we do that asynchronously. You don't have to. We actually, when we were doing it before, you were probably like, why is this method named that way from the file system? So the file system here, and we used read file sync because which you're not really supposed to use very often. And that is the synchronous version of read file, because normally read file is asynchronous. Because the reason for this is for performance reasons. And also like, we don't know how big the file is going to be. It could be huge. And like, we don't want to block the rest of our program from running while we're processing that file. We want to like kick off a process, continue the execution of our program, and then wait until that process is done reading that file. And then once it's done, then it'll give us the results of that file. Yeah. So we can look at that. So we can use, so let's pull in the file system up here.
So crazy, just,
No, it's like,
yeah, I feel like it listens.
It's weird that-
well, I have this file open. Yeah,
Oh, it looks at everything, doesn't it?
it looks at what you have open.
Yeah.
Yeah. Yeah. But what's really weird is I'll start laying out the plan for the class. And it'll predict the next line that I want to. So like, I'll type sync versus async and then I'll hit like, I'll just wait and then it'll be like promises. So like we can just like see like what would be the next thing that you should learn after this. You know, it just starts like
That's
listing stuff out. Yeah.
cool, though.
Okay. All right, so we pulled in the file system. And let's read a file. So we can, you know, we can kick off reading a file before we do anything else. We could say, you know, const file contents. Actually, sorry, we can't do that. Yeah, this is good. So we'll do fs.read file. And we'll use the normal one, not the synchronous one. And we'll read. Just we can read the readme for today. So just /readme. Okay, and in this version of that. The asynchronous version, we pass, here's the file I want to read, here's the format I want the response to be in, which this is just saying, give it to me as a string, basically, as text. And then since it's asynchronous, we have to use callback in this case. Okay, and the callback receives two things. An error, if there was an error, you may have passed a string that for a file that doesn't exist, or maybe the file was corrupted or something like that. And so if it couldn't read it successfully, it'll give you an error. And so you can check like, is there an error? And if there's not an error, it'll be undefined. And then data will be the contents of the file. So those are two things it passes you. So typically you'll see people do like, you know, if error something, some sort of error handling that makes sense in that situation. So we can do that. And then, you know, else console log the data, for example. All right. So your expectation, so kicking off the process to read the file is the very first thing we do in this program. That happens, like that order is there, and that telling it to read the file, it does happen synchronously, meaning like just go do that, that happens. But you know, and then we do the first name, last name greeting, and then this set timeout, and then this console log greeting. So in terms of this program, what do you expect to see?
Brings back the contents of the file.
Yeah, but what's the order? So we have three console logs. We have the greeting, the asynchronous greeting, and then the file contents. What order do you expect those to be logged?
I would assume
The reading and the readme.
Yep, and why is that? Well, maybe. I think that's correct, but maybe.
Just because the readme is small.
Yes.
and we
In
can
this case, yeah.
process.
Yes, so I would expect it to be able to read the file in faster than 2 seconds. But, and like, it would have to be a really big file to take 2 seconds. Like 2 seconds is a long time for your computer, really long time. So yeah, that's what I would expect. But we sort of don't know. We actually don't, there isn't a perfectly correct answer to that. Yeah, but that is correct. So yeah, we can run this. And we see, you know, our console log greeting, and then our readme is logged to the console, and then our async greeting. So yeah. Okay. And then notice, like, we could not, in this style, this asynchronous style, we cannot do const data equals fs read file. That's what we did before. We did, you know, const file contents equals fs read file sync. And you know, we told it, here's the file to read, and here's UTF-8, and we didn't tell it anything else. And it returned the contents of the file synchronously to us, but it blocked the rest of the program from running. It blocked and waited until that was done. So basically, if we had done it synchronously, then like first name, last name greeting, this set timeout, this console log greeting wouldn't have happened until after the file was read, which could take a while and is sort of considered bad.
It's
To
like
block
small, but
the
it's
program.
noticeable in that case, but like,
Yeah.
if it was like when I did call it, where it's like we had to go through like the entirety of Moby Dick or something, it would take a second to get through.
Yeah.
It'd be sick.
And so that, yeah, so basically kicking off this asynchronous read file, it doesn't really return anything. It's returning void, you can see down here. So there's no return value. It's just kicking something off. It's just kicking off a process. It's a side effect, basically. So yeah, we don't have the benefit of assigning that data to a variable and then being able to reuse it anywhere else. We only have access to that data inside this function, inside the callback, which then makes programming a little bit harder. So like if you want to process the data, you need to write a function to process the data and then call that function inside here.
Would that be like the stringify type thing, or something? What would you use for something like that?
How many, like, we might say like summarize the file, so, functions summarize contents. And we would take in probably just data. And we'd say like, how many data dot, like that, like how many times does code show up in the file, or, how long is it? How many words are in it or whatever? So yeah, we could do data dot split on like a space or something like that. And then do dot length or something, which is a rough approximation of how many words are in there. It's not quite correct because there could be periods or whatever. That would be okay. But well, yeah, we don't want to assign that, so we would do.
So you have access to information inside of the things there, but you can't do it directly from the whole file. Is that right?
Wait, say that one more time.
So like you have a number of words which you assign from the data that's in the file, you just can't assign the whole file to a variable. Essentially.
Well, this is assuming I pass in the correct thing here,
Yeah.
which I can only do where's the place that I can call this function summarize contents?
Outside of the read file.
What?
The function.
Yeah, in a read file.
Right here. This is the only place I can call it.
Gotcha. So it's only, well, okay, that makes sense.
Yeah. Well, it's assuming that we want to pass the contents of the file. So yeah, this is the only place I can do it.
Could do another function that's like return full contents of file outside of there, right? Instead of summarize contents. If you wanted to save the full contents for some reason.
Like you said save full contents?
If you wanted to set the full contents of the file to a variable,
You say you can't use that, so.
you create another function outside of that.
When you could do a global variable, couldn't you, and then assign the data that's in that file to this local variable?
And you're saying like assign a variable here, is that what you're saying?
Just like return.
Oh,
Save that function to a variable.
so you mean like,
Like how you would do it.
Yeah. Not what I'm getting at. Just
well, is this sort of what you're saying here?
Sort of, would that be possible? I mean, whether or not you want to do that.
So,
Really.
yeah, so. I mean, I could do something like let data. And then, in here, dude, well. Yeah. So I could do this. But I would extremely caution you from doing this because you don't know when that's going to happen. You don't know when it's going to update that variable. So there's nothing that you could write that can, any function or any code here that can rely on file data because it's going to be blank until the file is processed. And you don't know how long that's going to take.
It's gonna run.
Would that be more like,
Minutes.
Yeah.
that'd be where something like that, a wait would come in though, or something, where you wait until it knows that file is there and then.
Yeah, which I'll show you, but you still like. With async await, you can't do it globally in the file, you have to do it inside there's a function that has to kick off. All of that at some point,
I'm probably getting ahead of myself.
so I'll show you, but yeah, no, I mean, you're basically, you can't have. A global variable with the contents of the file in asynchronous programming.
Okay.
So you can't do that anymore.
So
There has to be something that kicks off a process that then once it's done and it's defined, then you would kick off whatever else makes sense. And in most programming is managed by functions. There's always like, you don't really do a lot of stuff globally in programming. You like have functions that get ran and then those functions call other functions and then.
that'd be the whole functional programming thing that we learned about, I guess.
Yeah, sort of. I mean, in programming, there's a concept called main, which is the main function that runs when the program starts. And for us, most of the time, that's like start the server and start listening for requests. And then you would get a request. And then that would call a function, and that might call another function, and that might call another function, and that it might call 10, 20, 30 other functions until eventually it returns a response, I think. There's always some sort of event that kicks off this like, Yeah, yeah.
Okay, right on.
yeah. All right, so yeah, we have this issue now where, you don't have that file of contents. You only have it inside this callback. And so that's where you can imagine callback hell happening, where you would like keep calling these other asynchronous things that then call the callbacks, and it gets like real nested. And so that's where, but I guess I haven't shown this quite yet though. Yeah, I did. I showed that. Okay. I didn't show summarize contents, but so let's do that. Just um I don't really know what was undefined. Oh, summarize contents doesn't return anything. And it console logs, so we just need to call it. We don't need to do that. Yeah. So our synchronous greeting, and then the contents of our file came back with, 44 words are in that file, and then our asynchronous greeting. Okay, so you'll see that callback style used still occasionally, but promises were introduced to make that a better programming style, make it a little bit easier to prevent the callback hell issue. So you'll be learning more in much more depth promises in the homework. But a promise is essentially like, hey, I promise you this will be something at some point. That's that's sort of the idea. So instead of providing a function a callback that it is sort of promising it will call for you, they changed it to like, hey, you can, with promises, you can kick off something asynchronous, and instead of it returning void, it'll return a promise to you. And so that's a wrapping type. It's like yeah. Yeah. But like in our example with read file, I said like, well, if I assign this, let me call this like, I was like, hey, load file here, or the loaded file contents or whatever, in this style here is void, it's nothing, because this read file function here doesn't return anything. So there's no sense in assigning that to a variable. But there is a promise version of read file that was added later, once the promise API came out. And so you can do file system.promises.read file, I think is. Yeah, okay. And we don't need this callback anymore. Okay. So this does make sense. So I can assign the result of kicking off that read file process to a variable in this case. Because in this one that I'm calling, it's the promise version, so it's gonna return a promise. So if you look at the signature by hovering over this, you'll see it's returned, the return type here is promise. And then it's got these like the little caret thing and these like little ellipses. Because what I said was promise is a wrapping type. So the actual thing that we want is the contents of the file, which in our case, when we ask for UTF-8 is a string, it's text. So technically, the full type of this load file promise variable is what people say a promise of a string. Like it will eventually be a string, but it has to go read the file first. So there's the promise is the wrapper of string. So like ultimately you're going to get the type you want, but since it's asynchronous, it's wrapped in the promise API. And the promise API makes it easier for you to code around the asynchronous behavior of it. So you'll see that in the homework, but basically it has a notion of that it's loading. It has a way to give it a callback, and it has a way to catch for errors. So instead of this like error data, if error do this, otherwise do this thing, the syntax for this looks more like load file promise dot then, and then dot catch like this. So there's this chainable. Hey, how's it going? Okay. Yeah, welcome. Basically we get this sort of, and often we write it this way, where we kind of do this like indentation, new line kind of thing. So basically the promise has a dot then method defined on it and a catch method defined on it. And dot then is like, hey, here's the promise. Whenever it's done, whenever the result happens, then run this code. That's what that is meant to say. And so this receives data, in this case, the contents of our file, and we can console log it. If something happens incorrectly, if there's an error or whatever, catch. I want to catch that error and do something with that error. And that's what this is here. Yeah. There's also something called finally, which is like, hey, after all is said and done, whether it was successful or it errored, do this. You may want to just have something that cleans it up, or that happens no matter what happens. But often you'll just see this dot then and dot catch. All right, so this is how we would do it with the promise. So let me just console log this. And we should see, we should just see the file log to the console. I'm not summarizing it like I did before. So we can run this. And you can see we get our console log, synchronous greeting, and then the contents of the file, and then the asynchronous greeting. So it ran exactly like what we did before. It's just a different style. So instead of using the callback style, we're using the promises style. Works the same, ran in the same order, all that. All right, so that's a very, very quick intro to promises. People don't like this style that much, actually, though. Like the dot then and the dot catch. Yeah. So promises are better, but then we added async await to make this style a little bit easier. Okay. So I want to just quickly show that. You have to set that up though. So we have to So I'm gonna comment this out. And we can add a function here. And I want this function to be a function that deals with promises. I want it to be asynchronous. Okay. I want to allow it to await for things, essentially. And so what you do is you mark the function as async, like that. You just say right in front of the declaration, you say, hey, this is an async function. Okay, and by doing that, you then enable the use of the await keyword inside the body of that function. Okay. So what I can do now is I can move this, like, so let's say I want to like load multiple files, or I want to like make multiple API requests, and I want to process all that information together. Or I need to like make an API request, and then with the response of that API request, I need to then use that to kick off another request. Then you'll often want to do that inside an async function, because you can, it feels like you're doing it asynchronously. Like you can write your code in a way that feels like it's synchronous, like do this and then this and then this, without having to do a bunch of .then or a bunch of callbacks. So I can do basically const so I can go back to what we were doing when it felt synchronous. Like, because when we were doing it synchronously, we just did here file contents equals file system.read file synchronously. Here's the file, and then assign the contents of that file to this variable. So this is enabling you to write it that way, but it's actually still asynchronous. So this function is asynchronous, but then if you use await inside the async function, it sort of feels synchronous. Though it's not. So it's still performant, it's still doing it the correct way. So this here, this fs.promises read file, that's returning a promise with the contents of the file, but then I'm awaiting that promise. And then by awaiting that promise, I'm then unwrapping it. I'm like getting the contents of the promise and then assigning that to this README data here. All right. This is like very advanced stuff. We just saw the notion of async await, and then we saw promises, and then now we're seeing using this async await with promises. So it's a lot all at once, but the homework will kind of go through this a bit more slowly. But now what we can do is we can take the README data here, and we can, if we wanted to, we could read another file. So we could we could do the syllabus, which is up one. Let's see, that's module 3. So now we can say, hey, get the README file, and then also get the syllabus file. But this is going to look like the way that this function will work is I could technically use README data like in the next, like I could use that here if I wanted to, because I awaited it. So it's sort of making it synchronous in terms of inside the execution of this function here. So I could,
I was thinking that's a sort of a cache file that we're building. Once that you called it, you're saying you could call it in other places and already.
inside this function, yeah. And it's not like this stuff is all happening in memory, so there isn't like an actual cache file, but yeah, in a way,
But it wouldn't release it either. It's not. gonna
Right.
send it out.
right. That's true, yeah. Yep, so like it'll kick off both these promises, but it'll halt the rest of the execution of the function until they both resolve. Assuming I use the contents of it. So if I try to use README data before, like inside this one, like it's gonna wait till we receive that data before it kicks off this promise. Yeah, so it is sort of turning it synchronous. So the function is synchronous, but the entire program is going to work asynchronously. Yeah. Okay, so we can, here we can do our summarize contents with README data. And then we could do our summarize contents with the syllabus. And then console log. Both of them together. So, I kick off a promise to read the README file. I summarize the contents. I kick off a promise to get the syllabus file. I summarize the contents, and then I console log both of them together. So in one line, I'm referencing both promises, the README summary and the syllabus summary. But this will work. This is valid. Because I awaited those two promises.
You forced it to wait until it had everything ready.
Yeah. So I just need to kick off this function though, somewhere.
The way it's written is definitely like overall it's kind of simple when it's written like that, but it's still just confusing to wrap your brain around at first.
Yeah. All right, so there's a few things commented out, but we define this function that's going to process multiple files, kick off those promises, summarize them and log the summary. But we don't actually run that function. We just define it. We then do this first name, last name greeting. We kick off this set timeout. We console log our greeting, and then we kick off process multiple files. So what do you guys think will be the order of this one? So what will be first?
First would be the regular greeting,
Mhm.
then, which is already there. Then I would assume. Do we still have to read the whole file, or is it it's just been reading process multiple files at the time now?
So we kick off the timeout, we log the greeting, and then we kick off the processing of the multiple files.
I bet that multiple files will finish before the timeout one at this point, just based on what we.
Yeah. I think so too. Yeah. I think we don't return it. The summarized contents is still logging.
And I thought that you kind of have a homework where like, why is this not working? Oh, I returned the right thing.
Yeah,
And then it's with them.
all right.
There we go.
Yeah. So the synchronous greeting, the summary of the two files together in one line, right? And then the asynchronous greeting in 2 seconds. Okay, so a lot all at once, pretty quick, but now you'll sort of at least recognize like there's this style of using callbacks, which we use all the time when we're using our higher order methods, like array methods, like filter and find and map and stuff like that. We use callbacks all the time. You can also use callbacks for asynchronous code. And the function will tell you, hey, this is an asynchronous function. It's gonna do stuff before it calls your callback. So you'll see that occasionally. And then now you'll also understand like, oh, this is a function that is returning a promise. So I can either do the dot then dot catch stuff, or I can put that inside an asynchronous function and await the result of that and sort of make it feel synchronous again. Yeah. So we will pretty much always use the async await style. It just requires you to put it inside an asynchronous function.
I guess that's just kind of the modern way overall. All of those steps can work archaic at this point based on how much you have to do to make it work right.
The like callback or the promise dot then stuff.
Mhm.
Yeah, yeah, so, yeah.
In this case, how would you handle your error statement? Just spell it out.
Oh, yeah.
Yeah, great question. So it kind of goes back to, so what people normally would do is they would do, we haven't learned try catch yet. But you would use a try. It's trying to do it for me. So we would do a try catch. And we basically say, hey, I want to do all this, try to do all of that. And then if there's an error, then I'll handle it down here. Is what I would normally do. You can also break it up. You could try the first one. And then try the second promise. But usually you're trying to do, like, we're trying to do something with both the contents of the file. So we don't care. We just like, if the first one fails or the second one fails, or both fail, which if the first one fails, it'll immediately kick the catch. So we'll catch that error and then we can do something with it. This is what we would do for that. But I haven't taught you all try catch yet, because you don't really need it until right now. Which is usually, I mean, you can use it for all kinds of things because you can throw an error in synchronous code, but most of the time you're going to be dealing with error handling when it's asynchronous. Because that's when stuff goes wrong. Someone's server's down, or the file's corrupted or whatever. You're touching something outside of your program, that's where stuff goes bad.
Basically, you have to work on anything else, wait, what that all contained, you know exactly what's gonna be there.
Yeah. Okay, so I want to show you real quick. The like, most of the time we're going to be talking over the internet with APIs. And so that's most of the asynchronous code that we'll do. So I want to show that real quick. So remember we kicked off a server in one of the, like, I think in the first class, we kicked off a server.
Yeah.
Yeah. So I think that was day one, we made this server, or actually ChatGPT made this server. So we pulled in the HTTP node module, which lets us create a server. And then we made a server, and notice, we're using that callback style here, which is like, hey, if someone makes a request to the server, then do this. Here's the code. And we set the status code to 200, which means success. We tell in the response, we say, hey, it's going, like, the response type is going to be plain text, which most of the time we'll be doing JSON when we get to it, because that's what our program can read easily. And then we just give it the text hello world. And then we kick off our server. And so kicking off the server is a process that runs forever. Like it's essentially a while loop of just like, check if there's been a request, check if there's been a request, check if there's been a request. It just like does that really quickly. So we can create our server and run that. And then with our program, another program, either in the browser or in Node, we can talk to that server. So I want to show that real quick. So first thing is But when we talk to that server, it's going to be what kind of code? Asynchronous code, yeah. So now we can talk to that server because we've learned how to do asynchronous code, yeah. All right, so I'm gonna make a second terminal, so I need one terminal that will run the server. So one run node program that will run the server, and then a separate program that's gonna talk with it. So I need I got two terminals running here. So I'm gonna go to day one and run the server, so node server.js. So the server is running. When we did this on day one, we just went to our browser and we went to localhost 3000 and we got the response hello world. So that's all we did. I'm gonna make a new file. Okay, so if we want to talk to that server, we're going to use what's called the fetch API. Actually, maybe we should do this in the browser. Yeah, I think we should do this in the browser. That's usually where we're going to be doing it. So this fetch.js is, let's change this to an HTML file. Because all the promise stuff we just learned is also in the browser. Like that's JavaScript stuff. So it's not node specific stuff. So I'll just put a script in here. Okay, so this fetch is just a built-in method available in the browser. In the browser, we don't often have to import the APIs, remember, it's just like defined in the window. So it's just immediately using fetch. The first parameter of that is the URL that you want to talk to. And if you don't give it any other parameters, it by default does what's called a GET request. So we'll learn more about the different types of requests you can make over the internet. But a GET request is like, give me something. And then there's other types of requests that are like, I'm going to give you something, or I want you to delete something, or I want you to update something. Those are the main types of requests that you make. So there's GET, post, put, and delete are the four types. And but GET is like whenever you went to a browser, like when we did this and talked to our server, by default, every browser, when you put a URL in the browser, that's a GET request. That's just the default behavior. So you have made GET HTTP requests all the time, and the URL that you're typing in is like the URL that it's talking with. So we can do that same thing. So in our code, we're saying, hey, we want to hit a URL, we want to do fetch. And if we just give it a URL and nothing else, it knows that by default, we want to do a GET request. So that's what this is here. Notice, like, I didn't do this code inside an async function, so I have to use .then. So it's using .then here. And in this case, it's assuming that the server is going to respond with JSON, which it's not. Our server is responding with text. And so we're going to get rid of that. And just console log the response. And then we want to talk to localhost. Okay, so that's all the code to talk to an API. You use the built-in fetch method. You give it the URL you want to talk to. And because talking over the internet is asynchronous, we have to use a promise. So fetch will return a promise to us. And you can either .then a promise, or we can move this code to an asynchronous function and await it if we wanted to. So let's just see what this is doing, and then I'll change it to the async await style. So how do I run this HTML file in the browser? Just making sure we still remember.
Okay.
Go live.
Okay.
Yeah, okay. So there's nothing on the page, so I'll open the console. Okay, and I made a boo-boo, made an error. So it's saying Fetch API cannot load localhost 3000. It doesn't know what URL scheme localhost is. What is the protocol that we use? Yeah, so I have to put HTTP:// Yeah, I just forgot. But notice like it's saying uncaught in promise, type error failed to fetch. So my promise through and I didn't catch it. I didn't have a dot catch. And so that's why it's saying uncaught. Like you didn't do anything to catch that error. So we'll change this to that. Try again. Oh, I have to do some configuration real quick. 1 second. Yeah, Course is this complicated web security thing, which basically makes it so that like, oh, like if you're like google.com is the only thing that's allowed, only browser URL that's allowed to talk to like a google.com API
Okay.
URL. But you can configure it to allow anything if you want. So I gotta set. Yes, how does it? No, I don't. So you have to set a header. To say allow any origin. So star is a wild card for any origin. So we'll see if that did it. Now I changed the code, but I have to restart my server because my. Hey, sorry, everybody. I think the internet kicked for a second. Maybe my server. Oh, ChatGPT failed us.
Oh, yeah, I was wondering whether there's an S on it.
Yeah, so actually my server crashed. Because, I mean, a lot happened at one time, but that wasn't valid. Okay, there we go.
Are you sharing your screen?
Oh, yeah.
Just.
Hey, sorry, everybody, about the drop. Okay, so now we got a response. So everything worked. And here's the response. And it's basically just a bunch of information about like what happened. So like the header, so it's an object with a bunch of data. So it has the headers in there, it has the status code, it has like who the server was often, like the server can give you headers that specify what it is, but then it will have a body. And we actually need to do something to parse that body real quick. 1 second. think that's. I think that's what we want. I usually always use the JSON, so I'm not as familiar with. Just reading text, but I think that's, we'll see. Okay, okay. So there's a JSON method, and I guess there's a dot text method to basically parse the response from the server. Okay. Okay, all right, so I had to, so I can get the whole response, or like most of the time you're interested in the actual text content or JSON content of the response. So I pulled that out of the response. And so now you can see like just hello world is being logged to the console. So the server responded with hello world, and I have hello world in my program, like in my front end program. So now you can see this connection that you can easily make between your front end and your back end, and like start making requests. Yeah. So we'll see this a lot more now. And you know, like the rest of the class is like, so we're almost done with this module. The next two are much more, yeah, much more advanced front end code with React that most of the time is like the advanced piece is dealing with how to get data from a server and show it on the page. So that's the big part of what we do in React, is making requests to a server to get dynamic content and update the page with it. And then the final module is, well, how do you make servers? Like, how do you easily create this content for the front end? So that's kind of what's left, but you can kind of already see here, like with this fetch API and promises, how you do the programming to connect the two. So I know we're over on time, and so we could have rewritten this to be async await. It's doing the promise.then style. But it's very easy to rewrite to, I'll just go ahead and do it. So we can do async function, you know, make request. It knows what we want. So we can kind of change this to be this async style, but then we just have to kick off that. Like when you make it an async function, there's an error here. Right here. Okay, like when you put it inside an async function like that, you have to call that function. So that you'll have to kind of write your code this way to just kick off that asynchronous method. But now you can see like we can await the fetch instead of doing the .then style, and it'll work the same. So usually people prefer this, it's just a little bit cleaner. Okay, cool. Good luck with the homework. It's just more detail on this stuff. So if this is kind of mushy to you, it should hopefully clear it up a little bit, and you'll be able to go at your pace.
That was set in my brain for sure.
Right?
Thanks, peeps on the call. I'll see you all on Wednesday.
We're looking at module 4.
No, we're in module 3.
Phase 1.
Yeah. So
2 days, right?
We're on day 3.
yeah, we have 2 more days.
With
I'll post it right now. 1 second.
Yeah, it's just blown by, especially my work.
yeah.